In this video I will try to explain why people who are allergic to pollen, they don't just suffer during the day but also during the evenings. Especially in the evenings. For example, in my case, I tend to sneeze the most at around 7 or 8 in the evenings, and that's every day the same. So why is that? Well, let me draw a few pollen emitters first to help you explain. So, flower here and a happy little tree over here. A guy with a big nose here. That would be me. And the guy is getting all these pollen from these plants and trees up on his nose, and at a certain concentration he'll start to feel the symptoms and start to sneeze and whatnot. Now during the day, of course, you get a lot of these pollen emitted by these flowers and trees, and of course if you're in a field with a lot of these emitters, you will get allergic reactions. However, during the day we also have the sun. The sun emits radiation, so UV radiation, and that hits the earth, and the land surface will convert this ultraviolet radiation, convert it to infrared radiation, depending on the color of the surface, which will then heat up the air just above the surface, and that will rise. So when air rises, of course new air will come in because you don't get a vacuum here, and it will rise until it gets the same density as the air surrounding it, and then it will stop rising. So new air coming in, this rises, will drop down again, and you get what we call an eddy turbulence. So these eddy turbulence, they mix the atmosphere, and these pollen, they get mixed up until the free troposphere, which keeps concentration relatively low. So let's draw this here in the schematic. So time on the x-axis, concentration on the y-axis, and this would be the concentration of pollen during the day. Like this. Okay. However, in the evening when the sun goes down, and let me draw this by this moon over here. So draw the guy again. Trees, flowers, Okay. So in the evening we don't have the sun anymore generating these turbulent eddies. So then the atmosphere becomes stable. So there's all these layers of air. And the top layer, that's what we call the PBL, the planetary boundary layer height. And you could sort of see this as a cap on top of the lower part of the atmosphere. And this basically and effectively traps all the emissions in the lower part of the atmosphere. So you get a very high concentration of these pollen and any other gas for that matter. So if we draw again the same diagram, we'll see that during the day we had relatively low concentration of pollen, but during the night, when the atmosphere becomes stable, concentration increases up until the moment where the sun comes in again, and concentrations drop down to background levels again in the morning. So this would be the early morning transition. This is when the atmosphere becomes stable, and here at, let's say, 8 o'clock in the evening is where the concentration are the highest, starting to get to be the highest. And that's when you sneeze a lot. Well, I do, at least. So I hope you now understand why it's not just a matter of how close you are to the pollen, but it depends on the atmospheric mixing as well.